Hello everyone. Today I'm going to show you how we can implement the sync leading list, okay, which is one of the technique in the data structure, or we can say in the short form as DS. All right. So not only the implementation, we are going to see the application, all right, of the sync leading list also. Okay. So before going to all those things, we are going to see the introduction first. So what do you mean by introduction in data structure? It said that it can be defined as a group of data elements which provide an efficient way of storing and organizing data in the computers so that it can be used, okay, efficiently. So we can say that, all right, we can say that data structure is the way that we store data as efficiency, okay, or efficiently in the computers, so that in the future you can retrieve or you can use data easily. This is the point, all right? So next thing, we come to see another example of data structure. Example is arrays, okay? Linked list, stack, queue, etc. Okay. So data structure are widely used in almost various aspects of computer science. For example, in computer operating system, compiler design, artificial intelligence, or we can say shortly AI, graphic, and memory more. Okay. As you heard previously, you can imagine that how important the DS work in nowadays world or in real-time world, right? Okay. I will tell you some more example. For example, okay, if you want to search some word, okay, in dictionary, okay, inside dictionary. Firstly, what you need to do, you need to search from the alphabet wise, right? For example, you want to search N, so you need to come to the A first, then you can find another letter. This is how, right, the words are arranged as efficiency. So it's same like in data structure also, that we want to store our data as, how can I say, like effectively. This is the point, all right? So next thing, what we are going to see, it is the abstraction, okay? So abstraction, we can say that data structure is simplified by ADT, okay? ADT is I think it stands for abstraction data type, okay? Abstraction data type, which provide a level of abstraction. The client program, okay? The client program use the data structure through the interface only, without getting into the implementation detail. So here, we can say easily in the abstraction is, it is the way that you hide the implementation thing, then you represent the interface thing, okay? You represent the interface thing, which is the, for example, if you design one mobile phone, right? You won't show to the client how the mobile phone was built, right? You won't show the motherboard and all. This is the point. But you show to the client is how it's used, okay? Which application it has, right? This is the point. Okay. The client or the end user, they won't concern too much whether how is what built, right? How motherboards get connected, how another like devices and all implementation, which program is used to create. They won't concern like that, but they will concern only how to use it. This is the point. All right. This is how abstraction is working. Next thing, we are going to see data structure classification. Okay. So this is we can say like the basic structure, okay, in DS. Okay. So here, data structure, it can be classified into two. First is primitive data type, or we can say primitive data structure. It can be like, I think many people have seen if you learn in the field of computer science. For example, int, char, float, double, anything, okay? This is how the primitive data structure. Next thing, non-primitive data structure. This is the main point that we are going to target, okay? That we are going to target it. we have linear and non-linear. Okay, it can be classified into two. First, linear. Second is non-linear. Now we come to see in linear first. Okay, in linear we have static and dynamic. So in the linear static we have array. All right, we have array, and the linear dynamic we have linked list, stack, queue. Right, but mainly what we are going to see today, we are going to see the linked list mainly. Okay, we are going to see linked list as mainly, and subdividers of linked list we are going to see the simply linked list. All right, okay, so we have done with the linear. Next thing we come to see non-linear. Non-linear we have classified into two types. First is tree. Okay, second is graph. Okay, we have tree and graph. That's it. Okay, next thing we come to see some basic definition of all those things. All right, now what is linked list? Okay, what is linked list? Linked list can be defined as collection of objects called nodes that are randomly stored in the memory. Okay, so we can say easily that linked list is act as the small memory, okay, or collection of objects. It's called nodes, okay, and is randomly stored in the memory, main memory. Okay, memory is called as RAM. This is the point. All right. Next thing, we can say that previously I have told you that the linked list is act to be at the node, right? Okay, which is stored randomly inside the main memory. Okay, so a node, okay, is contained two fields actually. It's contained two fields actually. The first on the left hand side mostly. Okay, we say that it used to store the data. Okay, okay. Next thing, okay, we have the link. Okay, we have the link or the pointer. Okay, or the pointer, right? Okay, as you can see here, right, we have data stored at the particular address and the pointer which contain the address of the next node in the memory here. Okay, as you can see here, we have first thing is data. Okay, it used to hold data, and this part it used to hold the address of the next node. This is the point, this one here we can call as link also, and overall here is known as node. Okay, it's known as node. And before it's starting, we have the head first. We have the head first from here. Okay, right? And just remember that at the last, okay, at the last node, you won't have any link, right? You won't have any link to another node. So the link part, it should be null value. Okay, it should be null value. Or we can say that the null values is represent end of the list. Okay, so basically the value is, we can say as zero only. Okay, it's nothing else. This is the point. All right, hope you guys are understanding. I think next thing, what is the use of linked list? Okay, what is the use of linked list? We can say that the list is not required to be contiguously represented in the memory. Okay, the node can be reside anywhere in the memory and linked together to make a list. This achieve optimize utilization of space. So it's not like it need to be continuously stored, okay, or contiguously. It can be randomly, anyway. Okay, node can be anyway. This is the point. Okay, so we can mean that node can be stored anywhere in the memory, right? Then it's connected to each other. No need to be like contiguously. Okay. Next thing, list size is limited to the memory size and doesn't need to be declared in advance. Okay. So the list size is limited. We can say that. Okay. And it doesn't need to declare in advance, right? So next thing, we come to see the empty node cannot be represented in the linked list. This I think you have clear, right? So like it means that the empty nodes, the empty nodes is not allowed there, right? This is the point. So next thing, we can store value of primitive data type or object in the singly linked list. Okay. So here we can speak easily that the primitive data type, like for example, in char, float, another like this, okay? We can use, okay, and store inside the singly linked list also. This is the point. All right, we come to see more. Okay. Previously, I have told you, right, about the basic of linked list. Okay. Now we come to see the singly linked list. Okay. Or we can say that one-way chain. One-way chain. Now let's come to see. Singly linked list can be defined as the collection of ordered sets of elements. Right? I think it's same with the linked list. Okay. Same with the linked list. The number of elements may vary according to need of the program, right? It depends on the need of program. It's vary on the need of program only. A node in singly linked list consists of two parts. As I have told you before that linked list is include of data part and link part. So data part of node store actual information that is to be represented by the node, while the link part of the node store the address of its immediate successor. This is the point. All right. Okay. So mostly is similar to the previous one. Okay. So one-way chain or singly linked list can be traversed only in one direction. In other words, we can say that each node contains only next point. Therefore, we cannot traverse the list in the reverse direction. So here is very easy to explain. We can say that the singly linked list, it doesn't have a double way of traversing. It has only singly way or single way, right? So we can say that it has only one direction. It doesn't have reverse direction. This is the point. Okay. So consider an example where the marks obtained by the student in three subjects are stored in linked list. Okay, so it's shown below here. Let's see. Right, as you can see here, this is the point how the singly linked list is working. Right, it's have only one way. From here, head, this is data, and this is the link to another address. Okay, this is data part, this is the link part, and this is the last data part of the node. Okay, and this is the null value because it doesn't have another value to link to. That's why it can be null. Or we can say that end of the list. As you can see here, it doesn't have the reverse side. It have the way of forward side only. Okay, from this one is forward. Backward or reverse, it doesn't have. Are you getting? All right. Next thing, we come to see linked list operation. Okay, so basically linked list operation, there are three operations. Okay, insert, delete, traverse, and one more thing is display. We can say that. So totally 4 or 3. Okay, sometimes it comes with 3. It depends. All right. So we come to see more. Okay. So traversal, okay, or traversing, like we access each element of the linked list. Okay, we can access each element, or we can say that we can like we can see or we can access every element or element wise. We can say that insertion. Okay, add a new element to the linked list. So this is very clear. Okay, deletion. The list is remove. We can say that remove the existing element. Search or search is mean like we find a node in the linked list, right? Or display. We can say that. All right. So here, okay. Before going to see how the singly linked list work, I'm going to tell you one thing. Okay. So as you can see in previous language, you have like if you learn C programming language, right? So the basic of storing data as efficiency way, we use array, right? Okay, and rather than this, we have we have like primitive type, right? Primitive data type, like int, something like that, right? You, for example, you declare the variables in a, something like that, okay? In a. So a actually can be store only one data, right? But if you come across the drawback of a or in, something like that, if you use a primitive type, you cannot how can I say, like, you cannot create more than one variable at the same time, right? You cannot create more than one variable at the same time. This is the drawback, okay? So it has one technique, it's called as structure, okay? So like we can create our own data type, right? We can create our own data type, like here. Example, easily example, struct node, okay? This is the name of new data type. Name is struct node, okay? And it has two members, okay? This is the variable. This is the pointer that we have declared inside. All right. So before going to see more, right? So this part, I'm going to explain you how we can explain or how we can implement the data structure in C programming language. All right. So I explain you in the field of algorithm wise. All right. So here we come to see words creating structure. Creating structure. Okay. Okay. So here we have like struct node. I have declared here struct name as node. Okay. And inside that I have one variable name as data. Okay. And I have declared one next pointer. Okay. Which is pointing to the struct node. The name is struct node. Okay. Name, the type name is struct node. This is the point. Okay. And after that, okay, I have created one node. Okay. We need to create node first. As we know, right? Simply linked list, you need to create node. You getting right? Okay. We need to use node, right? So here I have created node. So I have this is the function name, right? This is the function name create node. And this function, the name create node, type of this one is struct node. This is the point, okay? This is the name of type, struct node. And inside that I have one argument, or we can say parameter in num, this one, okay? So now we come to see more, struct node, okay? Then I have declared the new node pointer, which is pointing to struct node, okay? So new node, okay, equal to this one. So I will tell you how this one is working, which is I give this one the ball, okay? Okay, so here we want to see the size. We want to know the size of struct node, right? So the way how to see the size or know the size of struct node, we can use malloc, okay? Malloc and size of struct node. We write like this, okay? From here to here, this line. Then we know the size of struct node. We assign the value of struct node, like the address value of struct node to new node, this one. Then new node equal to the value address, the value address of struct node. Okay. Then new node point data. Okay. New node point data equal to num, right? This is num. You have declared here num. New node next equal to null, right? Equal to null. Then return new node. After that, when you're completing all things, is return the new node value. That's it. Okay. So this part done for creating the node. Now we have node already. So after we have node, so we need to insert the value, right? So we come to insert at the beginning first, right? So insert at the beginning, I have declared this part. Okay. This part is the function name. We have name as add front, okay? Add at the beginning, right? So add front is the type of this one is struct node, this one, struct node. And we have two arguments or two parameters. First one is in num, okay? Then we have struct node head pointer. Head pointer is pointing to struct node, right? Next thing, same thing with creating node. I have creating the new node pointer. which is pointing to struct node, right? Then we use this one. We assign the create node num, right? Create node this one, okay? Create node is holding the value num, which is we have right type, no? Then it will be assigned to new node, this one, right? After that, we come to the if checking condition. We say that if head equal to null, okay? If head equal to null, it print like it's come to this line, no? New node assigned to head, okay? New node assign the value to head. Whatever the value which is holding in the new node is assigned to head. That's it, right? Okay. So that means that head is equal to null. This is the point. Okay. After that, we come to else, no? Inside the else, new node next, okay, equal to head, right? In case of the head is not empty, okay? The head is not empty. It's come to this one. New node next equal to head, okay? Then new node equal assign the value to head. That's it. And after that, you need to return head the value. You need to return head value. That's it. This is the point. Okay. So we have done with the inserting at the beginning. So after that, we come across to the part insert at the end. Okay, or append. We can say that. Right. So here I have specified the name as append here. Right. So function name append is at the type of struct node. Okay. So we have two variables, in num and struct node head. Okay. Head pointer pointing to the struct node. Right. And declare two pointer here, new node and ptr, which is pointing to the struct node. Okay. So here create node holding num value. Okay. Assign to the new node here. Right. If then here head assigning to the ptr or ptr equal to head, same thing, right? Then we come to check in the if condition. If head equal to null, okay, then head equal to new node, head equal to new node. That's it, right? In case head is equal to null, nah? This part, right? Then we come to the else part. After checking if, then directly we come to else. We check in the while loop, okay? We check in the while condition. While ptr next not equal to null, right? That means we have done this. ptr next not equal to null. Then what to do? ptr next assign the value to ptr this one. Okay? ptr next from here, nah? From this part, assigning to ptr this one. Then ptr next equal to new node. And the last thing, we return the head value, this one. Return to the head value. So done with the append, okay, or insert at the end, right? So we have done with inserting. So what we need to do, I explained you deletion, okay, deletion. So here we come to see delete data from node. So this is the name of the function delete, okay, delete this one. And we have the type as in here, okay. So we have the two argument in num struct node, okay, and head here, head pointer which is pointing to struct node, and we have specified or declared two pointer p and previous, okay, this one pref pointing to struct node, both of this. Head assign the value to p, okay. Then we come to check the while loop. Why p not equal to null, okay, p not equal to null. Then we come if p data, okay, if p point data equal to null, then if p equal to head, right, then head equal to p point next. After that we free mean we delete, okay, we delete the value, right? Then when we delete we come to else, okay, in case of we done this one, no, right, we come to else. If we don't match with this one, we come to else directly. So inside the else, previous pointing to next, right, equal to p point next, then free the value, okay, free the value here. And if not in this one, we come to else again. mean here, right? After y here, this one. Okay. Like when we completing this, we come to else of the y here. Okay. So previous equal to p. Okay, and p equal to p point to the next. Right? And the last thing we need to return. We return the value as 0. That means completing the work. So what is the reason of returning the value 0? Because of the type of the function is in integer. So we need to return integer value. This is the point, right? Next thing, we come to see the traversing, okay? Traversing. How the traversing is working. So here, I have specified the type of the traversing. Name is in, and the name of function is counts, okay? Then we have one argument, okay? So struct node head. So head is the pointer name, which is pointing to struct node, okay? So n pointer pointing to struct node equal to head. Then c we have assigned as c equal to 0. Like we declare the variable, declare and defining variable, and assigning the value to 0 also. After that, we come to this part. We check in the while loop, okay, while condition. N not equal to null, right? N not equal to null. We come to here. N equal to n, right? Point to next. Then C++ and repeating again until the condition is true, right? It's false, sorry. And after that is return to C, right? Return C. Why we can return C? Because of C is equal to 0, right? So 0 is integer. That's why we can return to in here, right? Integer. Done for traversing, right? We have done for traversing. And the last thing what we need to do, we come for displaying, all right? So in displaying, I have specified the name of function as display. And inside that we have one argument, head pointer pointing to struct node. And after that, I forgot to tell this part, right? The display type name is void, right? Which is, it won't be return any value, right? It won't be return any value. And then R here, right? R pointer pointing to struct node equal to head. If R, okay, we come to check in if condition. If R not equal to null, that means R not equal to null, right? That means it's not equal to 0. We can say that. Return, right? Return. Or not, okay? Or not met with this one, okay? Not met with this one. It's come to this part. R not equal to null, okay? This part is R equal to null, no? If R not equal to null, that means it have some value in there, right? So if it have some value, so it need to display. So we use this one, printf, okay? This one, %d, right? /n. %d is showing that the value that we are going to present or display is belong to the integers, right? It are the same as integer. So we have display here, R point data, right? So after that, when we display R equal to R pointer next, right? It's display next. This is the point. That's it, what we have done for display, right? All right, guys, thank you so much. I think, hope you can understand what I have explained this today, right? I give you revision again, like we have done with the data structure, right? I have give you some basic example, basic definition, and then we have gone through the abstraction, right? Which is the concept, which is behind the implementation part. Then we display only the related to the user only, the end user. And after that, I come to explain you the linked list, okay? How definition and how we can use linked list, right? And next thing, we come across to the singly linked list, all right? So in singly linked list, I have talked about the mainly for I think for operation, inserting, deleting, right? Traversing, and displaying, right? Then after that, right, I have demonstrate to you like how the program is working, right? If you want to implement the DS in the field of singly linked list in C programming language, how we can write and how we can get output easily, right? Okay. So today, very thank you so much for come to watch my video. So I think we're gonna see again. Thank you so much and goodbye.